The three levels of scheduling from the Minix book of operating systems, design and implementation. So I have a question. What does an operating system have in common with a restaurant? Well, stick around and find out. First of all, we have a queue, a main memory, a disk, and the CPU. See this as part of a building. And at the bottom side, we have A, admission scheduler, which is a long term, C, which is a CPU scheduler, and B, memory scheduler. Here, all of the pieces of the puzzle. You have your parts of the computer and the schedulers. So let's see how this works out. To understand this, let's break it down with an analogy of a restaurant. This is the same idea, but with a more friendly story. First, we have a line of customers waiting outside and they want to go into a waiting room. The problem is that the room is small, so not all customers can stay in. So we need a middleman, someone who can organize the line of customers to wait into the waiting room. And for that, we have a host. This is the person at the door deciding whether customers can enter the restaurant. They only allow customers in if there is space in the waiting area. Next, we have the disk. That larger place works like another waiting area where customers can wait longer. So the main memory, the little waiting room, can only hold so much customers. So it needs extra space. And here is where number 3 comes in. But we also need a bridge, someone to control who goes in and who goes out. And for that, we have a manager. Manager B is the memory scheduler. When the waiting room becomes full, the memory scheduler moves some customers to a larger waiting room area outside. This manager swaps clients from the big room to the smaller room. Now we have number 4, the CPU. This is the chef. It can only cook for one family at a time, just like a CPU can execute only one process at a time. And for this, we also need a waiter. Finally, the CPU scheduler calls one family to go into the kitchen. There they speak with the chef CPU. So now we can see that instead of thinking of the operating system as a restaurant, it makes a little bit more sense how these numbers are related to structures. And the letters A, B, C can be represented as some sort of manager, so the people can flow correctly through all these structures, leading to the main goal, which is talking to the chef. Now, the stoplights is the same as these little managers. They're the same ones. Let's go step by step. First, we have the admission scheduler. The admission scheduler has some algorithm like first come, first served, priority-based admission. The admission scheduler is in charge of leading the processes and different states. For example, at the very end of the queue, we have a program. Once the program is inside the queue, it changes to a process. A process has its own state, just like clients have their states. One client might be hungry, another client might be in a hurry. So we have new process, process ready, process blocked. So this stoplight is in charge of administrating who goes in the main memory. As you can see, we have processes already in this memory and it's full. The memory RAM only holds a small amount of memory. Next, we have the memory scheduler. Some algorithms are least recent used, working set model, suspended processes first. Here we can see that this stoplight is in charge and deciding which process stays in the RAM or goes to the disk. The disk is a bigger room where you can have more processes and their different states, and swaps one process to the RAM and vice versa to the disk. Next, we have the CPU scheduler. Algorithms for this scheduler is first come, first serve, round robin, shortest job first, priority scheduling. And now when processes are in the memory RAM, the stoplight C is in charge of who goes into the CPU. And once again, the state changes. For example, from process ready to process running. And the CPU number 4 is in charge of that. Finally, the last step is process terminated. To have these words in mind, an operating system schedules at 3 levels. Who enters the system? Who stays in memory RAM? Who gets the CPU? Now, let's go back to the original image. On structure number 1, we have an arriving job, which is a program. It goes in the input queue, and its goal is to go to the main memory. The admission scheduler decides which job to admit to the system. The others are kept in the input queue until they are selected. Once in the memory RAM, number 2, when it's full, it needs to go to disk. Memory scheduler is in charge of that. The second level of scheduling is deciding which processes should be kept in memory and which one should be kept on disk. So memory scheduler swaps processes from main memory to the disk and vice versa. The last one is CPU scheduler. The third level of scheduling is actually picking one of the ready processes in main memory to run next. And that happens in number 4. So I hope this abstract idea of the 3 layers of scheduling is more clear. So now I invite you to do the same exercise so you can run it in your own words. One of the next ideas, for example, an airport, a hotel room, or the DMV. You have lines, you have people who are in charge of who goes next. So yeah, I'll read your comments on the bottom section. Thank you.